Okay, good morning. What a beautiful day. It's fantastic. I didn't expect this in Ireland to happen, but here we are. We will talk more about segregation dynamics today, so I want to follow up on the things that we talked about during the last two lectures already. Remember before the break, we set the scene, we talked about segregation, what it is and where we find it and what it could potentially mean. And on Tuesday, I started to get into this idea of the segregation process, right? Segregation dynamics, so that actually what we observe at the end of the day, remember, kind of the separation of individuals into distinct parts in social life, neighborhoods, workplaces, jobs, things like that. And we had talked about a common sense explanation for that, that people might not like different people, and that's sort of why we observe, which is a reasonable, perfectly reasonable hypothetical explanation, that we first need to go at and need to knock out that it's actually not the case. But then I kind of demonstrated you that this is not really in line with the empirical evidence that we have. Yeah, remember the key thing was that if it is because people don't like each other, then there should be less segregation in cities or in parts of the world where people are more tolerant, right? And I showed you this data with the north and the south of the United States, and I showed you that in the north people are actually more tolerant, or in the 1940s, 1950s, 1960s they were much more tolerant than people living in the south, but still we had approximately the same amount of segregation. So that's one of those things where and to a certain degree, sociology is all about that. Yeah? It's all about looking at the obvious and questioning the obvious and kind of, hang on a moment, is it really true, right? So don't buy into anything just because it makes sense. You need to show me some evidence for that. And here I'm actually showing you some evidence that kind of refutes the common sense theory that we had before, that it is about discrimination, or that individuals don't like others. So that was one thing that kind of changes in areas where people are more tolerant. And the other thing was that when there is change in time, as people become more tolerant, segregation should go down as well. And there was also empirical evidence for that. I showed you data from the 1940s going up to the end of the 1960s, where people became more tolerant. Fortunately, racism disappeared or it went down, but still the segregation level was the same. Same story here. We have some empirical evidence that is not in line with our theory that we suggested at the beginning. So what do we learn from that? Well, maybe this common sense theory is not right? So that's sort of the point. And that's also a little bit, and today I will at the beginning talk about this a little bit, about how we actually know stuff and how we model things and along these lines. But there we sort of got some evidence that suggests there must be something else happening here. There must be something else that leads to that. And to some degree, this is what this whole lecture is all about, that there are these social dynamics where the one thing changes the other, which changes the behaviors of others, which then changes situations for others, which then changes the behavior of yet others, and so on and so forth, right? And all these kind of things happen at the same time, or they kind of are all dependent on each other, and then at the end we have a macro level outcome that might be very different from what is driving the individuals to begin with. Yeah? So it's these feedback loops, these interdependencies that play a role. And next week, we will dwell more on these interdependencies. There I'm going to give you an introduction into network analysis, kind of stuff that I do, and then we will get much more into this, which is very cool to begin with anyway, but there's also an epistemological reason for that. Like, epistemology is the knowledge of how we acquire knowledge, how do we gain something, how can we make explanations. And there's a good reason here, because when you buy into this idea that there are these interdependencies that matter, then you need to look at network structures, because that's sort of the substrate on which social processes unfold. But more about that next week. So today what I want to do, I want to get back a little bit into this idea of modeling, yeah, and how this whole thing works, because I noticed maybe you guys are not really familiar with that, right? So maybe you haven't heard about that in your first year. So I'm going to talk a little more about that, and then I'm going to jump into these two segregation models that I wanted to introduce last time already, both from Thomas Schelling, the one-dimensional segregation model and the two-dimensional segregation model. But you'll see what I mean with that. Okay. Models and modeling. You know, that's one of those things that can be a little confusing, because, you know, we try, or you think we try to understand how the world works, but in essence, how can we ever know how the world works? It's really tricky. I don't know. How do we know that there are, I don't know, there is that this is how gravity works, or this is how electricity works, and so on? We don't really know. The only thing we can do is we can come up with a theory, and we can construct a model that kind of is in line with the theory. And then when we find evidence in supporting our theory, then we can say, okay, this is sort of a good theory so far, unless somebody else comes along and has a new idea about how things happen. And that's sort of the confusing thing a little bit, and I'll talk about that a little bit, is because it touches on this idea of falsifiability. Yeah. That essentially all the theories that we have are just theories that haven't been proven wrong yet. That's how it goes. Instead of proving that a theory is right, we actually prove that theories are wrong. And then the last man standing, that's sort of the most convincing theory that we have, and the most convincing theory that we work with. And to some degree, here models come into play. A model is by definition a simplification of the world. Right? I can build a model about, I don't know, how people behave, what they are going to eat, I don't know, or who their friends are. This is a model that I can build. I can have this doesn't necessarily have to be a statistical model. It can be a statistical model, but it can also be a theoretical model. Yeah? But what I think, what drives individuals' behaviors, and so forth. And then this model is essentially a way of rebuilding the world that we do observe. The idea behind that is that we can understand our model because we are putting all these pieces together, right? So in this little toy model here, you know, we know all the pieces that are put together to get something that looks like an aircraft, and then I kind of throw it, and then it flies, right? So the idea here is that model building or using models allows us to understand the ingredients that we put into our explanation, that allows us to understand whether the model is good in replicating the real world at the end of the day. That's one kind of model, replicating the real world. That's a second kind of model, and that's about having a theoretical idea and playing it out and seeing what are the consequences of that. Right? So I've been mentioning these things that, I don't know, some behaviors change the situation for others, for other individuals, which then might lead to them behave in a certain way, which then might change the situation for yet other individuals, and so on and so forth. What are the implications of that? Well, here a model comes into play, because now I can build a model with these rules. Essentially, these are sort of rules how we could think about how things are related with each other. Then often in these models there are some parameters as well, and we can estimate these parameters to fit our data or whatnot. That's sort of more the statistical part. But the idea really is that I have a set of little rules about how I think how the world works, how I think. Yeah? This is sort of my theoretical idea. And then I can look at, okay, what are the implications if this is sort of how it is? And then these two kinds of models, sort of the model that replicates the real world, and the model that we use for an abstract sense to make a more general point, they only differ in the sense that for the replicating the real world, I kind of tweak some parameter in my model, right, with the rules that I defined before, or we call it the data generating process. But I have some parameters in there that I wiggle in such a way so that my model comes up with something that looks like the real world. While when we talk about more abstract levels, that's not really what we want to do. Or that's not the main focus. There it's more about understanding what are the dynamics or what are the implications of the model. So this is a little abstract stuff, but I still think it's sort of useful to think about that once in a while, especially how we get to know things, right? So as I said, I'm teaching this stuff now with my first years because I think it's incredibly important to know how we know things. It's sort of the philosophy of social science, sort of the basis for all the things that we do here. And so therefore, just a few words on that, how we know things. Well, you hear a lot about, I don't know, you go to other lectures and people tell you about stuff, about different theories, this and that, right? And you scribble it down and then I don't know, maybe you understand it and you learn it for the exam and there you are, right? But I don't know about you, I was incredibly frustrated by that. I studied something else before and then I kind of switched into sociology and I barely passed my first sociology exams because I just couldn't get to grasp about what the hell are those guys talking about. There are all these different dudes, and they are old dudes with beards. When you look at those, I don't know, Weber, Durkheim, Marx, they're all massive beards. And then the one says that, the other one says that, and the other one says it's all about class struggle, and the other one here and there. I said, okay, so what is it? What is it? Now I was doing computer science before, I still do these kind of things. But there it's very clear there's an algorithm to solve a problem. I had a hard time to understand these different theories that are floating around there. And I had especially hard time that people seem to be satisfied with that. I was wondering, why is nobody rebelling here? Why is nobody saying, okay, now let's come to grips? And actually some good sociologists do that. They don't just say, this is sort of a theory here, this is another theory there, this is another theory there. I think the good guys, they go and test these things. These are sort of theoretical ideas about how we think the world looks like. The problem with people who are so entrenched into, I don't know, Marxism, or I don't know, if you go to see Kieran Allen today, he's one of those guys, he's just too far gone. There's nothing we can do about that anymore. He just sees everything through this lens, right? Instead of questioning, is this a theory, is this a model of the world that makes sense, right? And as a good social scientist, I think you're always objective. You always think about, okay, these are the different things. This is sort of the theories on offer. And now I go, and now I use observations, I use data in the real world to test hypotheses that I would derive from these theories to see which theory is the best one to explain the world. So that's sort of a way that I think makes much more sense than just getting into this, and it's not just Marxism, I've seen it with other people. I based half a year of my life on general systems theory of Niklas Luhmann. That's another one of those things that you can completely bang your head against the wall with, and I think it doesn't lead you anywhere. Right? So the idea here is, and that's essentially the scientific method. That's the scientific method that we are using. And I believe the scientific method we should use in the social sciences, and good people do use it in the social sciences. We have theories, and from these theories we deduce hypotheses that we then test with observations. And when we have observations of the world, we make generalizations of these observations to ultimately generate new theory. So that's sort of how the scientific method works. And now there are a few of those guys with beards, or actually at the time they had awesome hats and wigs. It's even older, that was what one had before. It's sort of a very short run through the philosophy of the social science about how we get to know stuff. Because there we have these general principles, and I hope that you have heard about these things before. We have deduction and we have induction. These sort of the very, very general things. And they play a huge role in terms of how we know things. And ultimately, what our models do. Right? So this is sort of how I'm embedding this here right now, a little excursion into the philosophy of social science. So there was this one guy, René Descartes. He I don't know, is mostly associated with this idea of deduction. deduction. I think we already had this before. René Descartes, I think, therefore I am. Right? So he said, okay, apparently I find myself thinking, and only things that think or beings that think can exist, hence I must exist. Now that's sort of the first deduction that René Descartes made, and then based on that he made other deductions. But the idea really is to deduce new knowledge from first principles. Something that we know is true. If that is true, then something else must be true. If that is true, then something else must be true. If that is true, then something else must be true, and so on. That's the idea of deduction, generating knowledge from things that we already know. The problem with that is that it gets a little wacky. Even with René Descartes, it gets a little wacky after a while, after his first, which is, you have to give it to the guy, it's sort of genius, I think, therefore I am. But after that it becomes a little strange, and it doesn't play out that well anymore. In contrast, there's this idea of induction. Induction is often associated with Francis Bacon. He sort of championed the use of experiments and real-world observations and data. So here the idea is we go out into the world, we collect data, we kind of look at how the data looks like, and then based on that, we kind of try to find a theory that maps that data that we observe. So there it's the primacy of the observations. Actually, Francis Bacon, he used experimentation a lot, which is a fascinating method. Funny side story about Francis Bacon. He was in London and had this idea. He had this idea, a theory, that when you cool food, that it stays fresh longer. That's a theory to begin with. So he said, okay, let's test this. So he took some chicken that he bought, chicken carcasses, freshly killed chicken, and he stuffed one of these chickens with ice, and the other one he didn't. And then he was waiting to see which one gets bad first. Well, and that's sort of how he has a theory, and then he kind of uses empirical observations to look at that. And he was right. Actually, the chicken with the ice inside stayed fresh longer. The funny story is that while doing so, he caught pneumonia and he died. So that's sort of a freaky, funny way how Francis Bacon died while he was experiencing with dead chicken and some ice. Anyway, so there's also David Hume, but let's not bother about him right now. The story I want to bring home is the difference between the deductive and the inductive approach. So you see, in the deductive approach, we first have our theory, right? And our theory, we can represent that with a model, and it comes up with something that we would expect. In this case, we're looking at the relationship between hours that you guys study for the exam and the grades that you will receive at the end of the day, right? So that's a very simple story. Kind of when you study more, you will get a better grade. Well, if you don't study, you will get a bad grade. That's as simple as that. And that's sort of what this theory would predict in terms of how this relationship looks like. And then I can go out, at the end of the term, I see the data, I see who was here, I see who was active in this, I see the assignments that you guys handed in, and I see the end of term exam. I grade it, I get your grades. And then I can relate this with each other, and then I kind of get some empirical observations. Now this is sort of now represents the empirical observations that I have, and this is sort of how the real world looks like, right? And then I go and compare my real world observations with the predictions from my theory. And then if that sort of matches with each other, I can say, okay, my theory seems to be good. My theory seems to come up with a good model of the real world. My model seems to replicate the real world in a good way. And if that's not the case, well, then you would have to refute your theory and come up with a new theory. While in contrast, the inductive approach starts the other way around. So in the inductive approach, you start with the data, right? So the first thing I do is I look at the data. Let's say, I taught this course elsewhere last year, And I recorded their hours that students studied or how engaged they were in the class. And I also recorded their grades at the end of the day. And this is sort of the empirical observations that I had. And this is sort of the data. And then I looked at that. Yeah. I looked at that over the break, and I thought, hang on, looks like there seems to be something going on here. There seems to be a relationship that goes like this. There seems to be a relationship between the amount of effort that students put in, surprise, surprise, and the grade that they get at the end of the day. Right? And then based on that, I would create a theory that kind of represents this relationship. But it's sort of, you see how the difference is in the inductive approach. You start with the data, while in the deductive approach you start with your knowledge that you generated before through from first principles or from theories. In practice, we do a bit of both. Yeah, we put them together. We use a deductive approach to generate new theories, and then we use induction to test theories. And sometimes we have surprising results. We have results that don't fit with our theory, and then we also use induction to generate new theories. So that's sort of a little excursion as the problem of induction, but let me not get too bogged down by this, because essentially what I wanted to go to was using this idea of models in the context of segregation. Okay, so now there are two segregation models that I want to talk about. Both go back to this guy, Thomas Schelling, genius in the field. He won the Nobel Prize. He's just a super intelligent guy. He outlined these models in his book, Micromodels and Macrobehavior. The shorter version of essentially the same two models is in the article from the Journal of the Mathematical Sociology. It's the article that was on the required reading list. Okay, so let me first start about this one-dimensional segregation model. Yeah. So now these models, they are in a very abstract models. They don't aim to replicate the real world. Schelling uses models to kind of look at what are the implications if certain rules hold. Right? So what is the outcome of that? And then the logic is by showing that rules that might have nothing to do with segregation or only a little with segregation can produce a large amount of segregation, we learn about this segregation process. And then people actually start combining these different approaches where they kind of use a Schelling model in an empirically calibrated way to actually replicate real-world segregation patterns. But that's incredibly difficult. That's not that easy, because fitting these models is difficult, and because there's a whole bunch of dynamics, feedback loops going on, and so on. That's very, very difficult. So let's talk about this one. The idea is, as I had already outlined before, let's say with segregation, individuals live in a certain environment, they evaluate their neighborhood, right? They see, for example, how many other people live here who are similar to me, how many other people live here who are different to me. People evaluate their neighborhood, then based on these evaluations, they act, right? They do something, say they move away if there are too many people who are different from themselves. Remember the example of the cocktail party that I had last time? I don't know, if you're the only female surrounded by a whole bunch of dudes, at some point it gets uncomfortable, you go away. While the same thing is when, you're the only guy surrounded by a whole bunch of women. You might be uncomfortable as well, or you might be comfortable, depends. But then that might trigger some action for you to go on. So the context actually matters, right? That's something I think is very important when you talk about the social world, because it's about the social world. Things around us matter. Social contexts matter. We are embedded in social context. Individual action, and that's sort of the last step here that I've been telling you, that these individual actions then also change the environment of others. So when you leave a group, the composition of males and females in that group changes. When you join another group, the composition of males and females in that other group changes. What does it mean? well, maybe then somebody else gets uncomfortable who was not comfortable before, who was comfortable before, right? But because you left, then somebody else, and hang on, now I'm the only guy here. Maybe I should go somewhere else, or maybe now I'm the only female here. Let's go somewhere else. Right? So, and then we are back at this idea of thresholds, that we had about before, where I don't know, the one guy riots when the other one riots, when the other one riots, and so on, and that sort of can play out here. And then you see when individual changes neighborhoods, wow, it affects the evaluation of neighborhoods for others. There we are. Now we got our feedback loop closed. Okay, so let's get started with this, with a model, and let's start with the evaluation of neighborhoods. So what Scheller introduces, the first one is a one-dimensional segregation model. Now this is sort of a very abstract model of the world, where he says, okay, now let's just think of a unidimensional town. It's basically just one line, right? It's just one long line, and there are two kinds of individuals. There are circles and what's the name of the other sign? I don't know. No. Anyway, there are circles and non-circles, and they alternate in whatever. They're just completely set up there by chance. They represent now two different ethnicities or two different groups or two different sexes, whatever. Right? So, and each piece belongs to one of these groups. And this is now an example of how this world looks like. It's just one long line, right? Actually, he set this up with 70 pieces. You see, this is very abstract. This is very abstract, but the point here is to kind of outline these segregation dynamics. Yeah. So there's a long line of pieces. They belong to the one or to the other group. There we are. Okay. So now he goes on, and now he defines a neighborhood in this paper in the Mathematical Sociology article. He defines a neighborhood that says, okay, now the neighborhood for one individual consists of the four other pieces to the left and the four other pieces to the right. That's the neighborhood. Plus myself. I'm part of my own neighborhood as well. So for each individual, there's sort of different neighborhoods. Now you see, this is sort of now the neighborhood for the red individual. This would be now the neighborhood for another red individual. 4 to the left, 4 to the right. And these are all the things that are being, that you can then change later on. That's sort of what people then study. And how does that differ when I define the neighborhood in a different way, and so on. So these are all subject to the thing. But here they don't actually really matter whether it's a small or large neighborhood. Now, when you look at the composition of the neighborhoods, you can count how many circles there are and how many non-circles there are in the neighborhood. Here in this neighborhood there are 5 circles. Right? 1, 2, 3, 4, 5. And there are 4 non-circles. 1, 2, 3, 4. Right? So that's sort of what the composition of the neighborhood is. For this guy, sort of the same thing. There are 5 circles. 1, 2, 3, 4, 5. And 4 non-circles. 1, 2, 3, 4. There we are. So both neighborhoods in this case have the same composition, of circles to non-circles. Okay, now these pieces in these neighborhoods, they can represent households, they can represent individuals. Remember how I said that how these things can be applied to all sorts of things. And the important thing is that now there's sort of an interdependence embedded here. There's an interdependence between individuals or households or whatever they are, through the composition of their neighborhoods. Okay, so now these kind of models, they go in rounds, right? So there's something, one individual does something which then changes the world for others, and then somebody else does something which changes the world for others. So the way we look at these things is in rounds. So this model is this idea that there's this dynamic process. Okay, so now what Schelling does, you have to give it to the guy who was doing this in the 1960s, sitting there with no computers or anything, just his imagination. And later on he was using checkerboards, where he moved pieces around and so segregation unfolding, unhappening. Now he comes up with this simple rule that individuals have a threshold, right? Sort of a threshold model, meaning individuals don't do anything until their threshold is reached. When their threshold is reached, they do something. That's his idea. And here, the idea is that individuals stay put with a certain amount of others in their neighborhood, while when they start feeling they are in the minority, then they go elsewhere. So now what Schelling does in his mathematical sociology paper is he looks at the threshold of 50% similar individuals nearby in the neighborhood. As soon as there are less than 50% similar individuals in the neighborhood, he says the individuals are unhappy and they try to resolve that. And when you apply this very simple rule, well, you find these guys here, the yellow pieces, are unhappy in this situation. Why are they unhappy? Well, let's look at this guy. This guy's neighborhood consists of the 4 to the left. Well, there are only 2, so there are only these 2 count, and 4 to the right. And when we look at that, there are 2 non-circles and 4 circles in his neighborhood, right? So there are clearly less than 50% similar individuals in the neighborhood. Yeah. In this case, there are only 33% similar individuals in the neighborhood. That is why this guy is unhappy. For this guy, a similar thing holds. Now we have sort of 4 guys to the left and 4 guys to the right. So what we see here now, well, there are 4 non-circles, 1, 2, 3, 4 in this guy's neighborhood, and 5 circles in this neighborhood. So again, there are fewer similar individuals in the neighborhood. And that's sort of what we set up here for how we defined individuals being happy in the neighborhood. That there needs to be at least 50% similar nearby. And so on and so forth. So just by looking at the world, how it is right now, we can identify who is unhappy at this particular moment. You know? Okay. So that's sort of the first step. Identifying who is unhappy with this world at this particular moment. Now we mark them. And that's sort of how these models actually go. They just go and they mark them. They color them, remember, okay, this guy is unhappy, this guy wants to do something. Okay. Okay, then the model moves on, and Schelling. Okay, well, first of all, there are some other things about these rules that Schelling applied, about people being unhappy when they are part of the minority groups. Well, first of all, it sort of goes along with this idea that individuals would prefer segregated over completely integrated neighborhoods, right? That, I don't know if you can choose between an environment where everybody is similar and an environment where everybody is different. Most people go for the environment where everybody is similar. There's some empirical data for that, so I'm not making that up. There's empirical data for that. Actually, this model also goes along with this idea that individuals prefers a mixed neighborhood to any other composition. Right? So people would be absolutely fine in this world with a 50-50 split. Remember? So people actually would be happy with a 50-50 split. That's sort of the individual preferences that we are modeling here. But as the result, as you will see later on, we still end up with the segregated world. Although individuals would be perfectly fine with a 50-50 split. Okay, so basically the assumption that he makes, they are in line with assumptions for preferences for integration. Okay, well, there's nothing new. There's nothing new that I haven't really said yet. That individuals are optimistic. They actually could prefer an integrated world, but the outcome of the model, as you will see, is that extreme residential segregation can emerge even under seemingly favorable conditions for integration. Okay, so how does now this next step look like? So individuals evaluate their neighborhood. Now we're talking about this model. Yeah. So with these models, you need to buy into these models for a moment. You need to understand them. Okay, this is sort of the assumption that this guy makes, and of course then you can criticize all the assumptions that people do, and then people extend the model and kind of show actually how does it actually play out in the real world, or what are sort of other things that kind of matter here. But for the point of the paper. The relevant thing are these dynamics that are embedded in it. So now individuals evaluate their neighborhood, and after they evaluate their neighborhood, they base their action on this evaluation. They do something. Okay. They take a step or they don't take a step. They move out of the neighborhood or they don't move out of the neighborhood. So now the rule that Schelling applies is that a piece that is unhappy moves to the nearest point between two other pieces, to the right or to the left, where it is not a minority. So now there's this guy, remember, this is sort of our first unhappy piece, the yellow dude, and now this guy is going to move to the neighborhood that is, so he's going to move out. He doesn't like that, so this is where he was before. He moves out, he leaves that neighborhood, and now he moves elsewhere where he actually would be happy. He takes as few steps as possible to the left or to the right to find a position where at least 50% of the individuals are similar to him. And if you look at where this position is, it's actually in here. So basically this guy then squeezes in there. Right? Show this again. Here we are. He squeezes in there because at this neighborhood where he is right now he has 4 guys to the left and 4 guys to the right. And now you see there's 1, 2, 3, 4, 5 non-circles and 4 circles in this neighborhood. So this is where the guy is actually happy. Right? With this rule that we applied before, that there should be at least 50% similar individuals in the neighborhood. So this is where he goes. And this is sort of already the whole model. This is already the whole model, to identify individuals that are unhappy and then move them according to a rule, right? And now you see, okay, I can do that with all the individuals that I marked unhappy before. And that's exactly what Schelling does. Now he marks all these individuals that are unhappy, and then he applies this rule. And by applying this rule, and that's the key, those individuals, they screw up the neighborhoods of others. Yeah? They change the neighborhood of others. They change the neighborhood of those where they left, and they change the neighborhood of those where they squeeze in. This is what we see here. So this guy, remember the yellow guy, we moved him from the empty spot to where he is right now. He left the first neighborhood. Who was in this first neighborhood? Well, all those other guys. So he was a neighbor for all those other guys. For all those violet guys, he was a neighbor himself. So now by having gone, those violet dudes need to reevaluate their neighborhood because suddenly there's one non-circle less in the neighborhood, right? So now their composition changes of neighborhoods. Yeah? Maybe now they become unhappy. At the same time, our new yellow individual changes the world due to his arrival in a new neighborhood. By squeezing in somewhere, he changes the neighborhood of some other guys. Right? So he changes the neighborhood of these 4 guys because now suddenly he's a neighbor for them, and he changed the neighborhood for these guys. Well, you could say, well, actually he should change the neighborhood for this guy here as well, but practically he doesn't. Why? Because before he was there was another non-circle in here. Now he's squeezed in, being yet another non-circle. So for this guy, the neighborhood composition didn't really change. There's just another new circle, non-circle for one that was pushed more to the right over there. So technically speaking, this guy's neighborhood is a different one now as well, but it doesn't have an effect. He's not really affected by it. Same thing for this guy. Actually, I should color this guy here green as well. So people are affected by leaving or arrival of the piece, but it does not matter because the neighborhood composition doesn't change. But for some pieces, the neighborhood composition might change. Yeah, and there we are, and then we go to the next route. You see, now we basically start again with this new setup that we have. And now we could apply the same rule, go through it again. Who is unhappy now? Who's happy? We mark them, and then we apply the same rule that we had before, finding new positions to the right or to the left with the minimum cost. And that's essentially what shelling does. You kind of place these out in rules, go back and forth and forth and forth, and then eventually, this third round and so on, and eventually what you see is that this thing that we reach what we call equilibrium. We reach a stable state where eventually everybody is happy. And this is now an example from Schelling's book. He starts off with a world like that. Instead of marking the pieces yellow, he underscores the ones that are unhappy. Then he kind of moves them according to the rule. And then he underscores the ones that are now happy after the second round. He applies the rule, and this is what he ends up after only 2 rounds. And when you look at that, well, this looks like a pretty segregated one unidimensional world. Whatever a unidimensional world is, got a long line, but there are circles and there are non-circles. Although, in theory, everybody would be fine with a mixed neighborhood where 50% individuals are similar only. They would be fine with that, but we still end up in a world where almost everybody is surrounded by similar individuals. Well, that's the one-dimensional segregation model. Now, the two-dimensional segregation model basically just takes that to the next level. Yeah? And instead of just looking at the one-dimensional town, now he looks at a two-dimensional world. It's still very abstract. These things are very abstract, right? But at least we can look at them. And basically, this guy Schelling, you have to give it to him. He was playing this on his checkerboard. He was putting out coins, and heads and tails, and kind of arranged them on the checkerboard. And then he identified who is unhappy now. It's the same story. But now instead of just looking at 4 individuals to the left, 4 to the right, now he looks at, okay, who's living, who's around, who's surrounding that individual. And again, there are different definitions of the neighborhood. You can have sort of the 8 individuals immediately around it. You can go further out. You can, have only smaller ones for Neumann neighborhoods or whatnot. But that's sort of, things that you actually change and that you can study at how do these changes play out. But here now, let's say, the rule is that individuals stay if at least a third of their neighbors are similar to themselves, right? So this guy would stay, but this guy, according to this rule, is unhappy because there's only one similar guy in the neighborhood, while there are 1, 2, 3, 4, 5 dissimilar guys in the neighborhood. So then this guy would move somewhere else. There are different rules how you can move somewhere where you are happy or move somewhere where it's an empty spot or whatnot. And this is sort of what then Schelling does. He sort of populates a world. This is sort of like a checkerboard that he has. He puts the circles and the non-circles somewhere, and there are also some empty spaces that are not occupied, some empty houses or whatnot. And then whenever somebody is unhappy, he moves this guy to an empty spot. That's the simple rule. Right? It doesn't have to be any more fancy than that. Just identify who is unhappy according to a threshold, right? According to the composition in the neighborhood, and then move them elsewhere. And then you can actually simulate these kind of things, and that's sort of something that I did. And you see is you get a lot of segregation coming out of that. So let me quickly show that to you. So this is sort of the stuff that you've already seen before a bunch of times. This is essentially the two-dimensional segregation model. Now we have reds and greens, and the black dots and sort of empty spaces. Right? We can set up our world. I can change the density. That means how many empty spots there are. Right? These are sort of things that I can then study. How does the number of empty spots kind of affect the outcome that we have here? I can set this somewhere. Let's say 20% vacancies, and then I can set a threshold. That's this idea of how many similar individuals do I want to have in my neighborhood. So here now the threshold is set at 30%, meaning that individuals are perfectly happy when there are 30% or more similar individuals nearby. But as soon as there are less than 30% similar individuals, they become unhappy, they move elsewhere. Right? And then I can kind of identify, actually now when you look closer, the X's are the ones that are unhappy right now. right, at this initial setup. This is just a random setup. And you see there are, most of the people are actually happy. Only 60% of the individuals are unhappy at this particular moment. Okay, now I can apply this rule. Take one step. Take everybody who is sort of unhappy right now and move them elsewhere. Actually, now I set it up that I just picked. Now I picked one individual who was unhappy and moved this individual elsewhere. Now I pick another individual who's unhappy and move this back. Take another one, 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 and move them elsewhere. Right? I can play this out. Well, this is now what we call asynchronous updating, because I always take just one single individual, make a move, and then I reevaluate the neighborhoods of everybody else. Synchronous updating would be if I mark everybody as unhappy, and then I move individuals, and then I use the information about happiness from the last round. Basically, I go in rounds instead of kind of updating the world after every single move. Okay, you see, actually now I reach sort of a state where now everybody is happy. Right? So all the unhappy people were satisfied. They were relocated somewhere else, and if they screwed up the neighborhood, those guys got satisfied as well. And what you observe is that it pretty much looks like a segregated world, right? Not as strong as before in the one-dimensional case, but still, individuals, although they would prefer, or they would be absolutely fine with only 30% similar individuals nearby, we end up in a scenario where, on average, 70% of the individuals in the neighborhood are similar. Right? So now you see the difference. How we get segregation, although individuals actually would be fine with integration. You can have the whole thing in a synchronous updating. So now this is sort of the case where I'm just taking all the individuals that are unhappy right now and I move them. And after I moved all those individuals, I reevaluate the neighborhoods of everybody. Then I look at who's unhappy in the next round. Who's unhappy now? Who's unhappy now? Who's unhappy now? And if I apply that rule, it only takes me about, 8 steps, 9 steps, 10, still have one unhappy guy. Here we are. So now everybody is happy. So in only a few steps like that, I end up in a very segregated world, although individuals actually would be very happy with living in a much more integrated world. Okay, so that's sort of the Schelling model. What do we learn from that? Well, the model shows that high levels of segregation can result from rather tolerant individual preferences. High levels of segregation can result from both tolerant and intolerant preferences. And it now makes this micro-macro link explicit. And this is sort of where there are many different ways how you can do that. You don't have to do it like that. But these computer simulations, I think they're very powerful because they let us play out, they let us define a model that kind of link the micro to the macro level, and then we can play out what are the macro level implications if we instill some simple rules on our individuals, and if we instill some simple interdependencies about how social contexts matter. Schelling's model of segregation improves on the common sense theory, both empirically and theoretically. Remember, the common sense theory was that individuals don't like others. Now, empirically, we see that we can have segregation regardless of some individuals being more tolerant than others, or I could show you if I change this threshold up and down, there's not much difference. If I have 30, 35, or 40, or 50, or 60, or 70% thresholds that individuals want, we always end up in a segregated world with approximately the same level. So this sort of takes away this linear relationship that you guys probably grew up with and are thinking about all the time. It's sort of some big effects must have some big effects must have some big causes. But here it can, because of these feedback loops, because of these dynamics, the things don't matter that much. Although when I go smaller than 30%, there is sort of this value in between from which onwards it actually does matter and it changes. So there's sort of this crucial threshold value in the middle. Theoretically, it improves on the model because it kind of links the micro to the macro level. It kind of essentially produce the macro level phenomena through individual behaviors. We can talk about different threshold functions as well, about how we actually model. These are sort of extensions if you're interested in that. I think it's a very fascinating field of study, especially this kind of thing where we can model that individuals don't just have a simple threshold, but they have a certain preference to live in a certain neighborhood, and then maybe this is a continuous function. And then some folks at Cornell, I remember when I was there, they wrote a paper that kind of models something like that, which basically gives individuals, prefers to live them, it builds a model where individuals prefer to live in a highly integrated world, but if they have to choose between a world of all dissimilar and all similar, they go for the all similar. That's sort of the thing. That's basically what this line here represents, this going up and down. You see? So this line here, the solid line here represents. And the outcome is that we still end up with the segregation in that scenario. Anyway, you can also study these things empirically and so on, but let's leave it there. For next week, I'm going to give you an introduction into network analysis in general, and for both of the sessions, for the first one I give you an introduction to networks in general, and then on the second one we'll talk about this weird thing that your friends tend to have more friends than you. And actually, I wrote this paper, published 2 years ago, and we'll talk about that as well, that your friends do not only tend to have more friends than you do, but they also tend to be better looking than you. So this is what we're going to talk about next week. Thanks.